Hi, I'm Rich with insideHPC, and we're here at SC12 in Salt Lake City. We're here at the Portland Group, and I'm here with Michael Wolfe, a programmer from the Portland Group. So, Michael, I was hoping you could help me out with something here. I've been reading a lot about OpenACC, and could you tell me about the history? How did this thing come together, and what's it about?
Well, I'm glad you've been reading a lot about it. There certainly has been a lot of press and a lot of excitement about OpenACC. So the thing came about because several years ago, PGI introduced the PGI Accelerator. Let me start that sentence over. Several years ago, PGI introduced the PGI Accelerator programming model, directive-based programming for NVIDIA GPUs, and was reasonably successful. And a great deal of the community said, well, maybe we should standardize something. And so the OpenMP committee said, let's look at accelerator directives for in the OpenMP venue. And they started an OpenMP subcommittee. And Cray wrote a proposal, a starting proposal for the directives. It was based largely on the PGI model. Had some important additions and changes. And we're working on that in this accelerator subcommittee. And Cray is co-chair of that committee. And Cray actually started implementing those directives in their compilers. And then Cray got the contract for Titan. And part of the requirements was to deliver a directive-based compiler for programming those accelerators, those Kepler GPUs that they were going to get. The customer did not want to be dependent on CUDA. And so it was very important that they had a set of directives that was going to be accepted. And so they were pushing very hard inside the OpenMP committee. And then that customer and others said, we're not going to accept a vendor-specific solution. It has to have the blessing of a standards body. And that was the genesis of OpenACC. Wiser heads said that PGI has something, Cray has something, they should spell it the same way. You guys get together and do something together. And so that's what we did, and that's how we came up with OpenACC. So the members now of OpenACC the vendors are all members of the OpenMP committee and the OpenMP Accelerator subcommittee. And we are hoping for convergence. That has always been the plan. We were never intended to set up anything in competition or separate from OpenMP. It was intended to produce something fast, get user acceptance and user feedback, provide the feedback to OpenMP, and then move forward inside the OpenMP committee.
Michael, I love this story about OpenACC because it shows that diverse companies getting together for a common goal, right? And in that vein, it seems like the next level, the door is open with the OpenMP folks, that maybe there's going to be another level of convergence. And I wonder if you could tell me what's happened recently with OpenMP and this standard. Are they going to become one?
That's an unfortunate story there. So when OpenACC was formed, there was a lot of anger and ire amongst the other OpenMP members, the OpenMP Accelerator members. Unnecessarily so, I thought, but there was some discussion that the OpenMP boogeyman is going to get you. I'm sorry. The OpenACC boogeyman is going to come and get you and drag you away in the middle of the night and make your programs incompatible. And this is silliness. So a lot of unfortunate and nasty words were spoken at the time. That settled down a little bit. The OpenACC members all continue to work inside the OpenMP Accelerator subcommittee, and we were all hoping for convergence. And I'm a big believer in the OpenMP process. When we had this OpenMP Birds of Feather session 3 years ago on accelerator directives inside OpenMP, everyone agreed it's the right venue, it's the right people. I had a position paper, I defended that. But that process broke down. After almost 2.5 years of accelerator subcommittee work, a subcommittee got together and jammed through this target proposal and got it accepted. It's very attractive, but it doesn't really matter how attractive it is if you can't really implement it. If you can, it's great. And for the targets where you can, it looks very attractive. But the process broke down. That's not the way OpenMP is supposed to work. That's not the way these committees are supposed to work, and I'm really disappointed in the way that happened.
Well, I can understand that, but at the same time, Michael, I look at OpenACC and it seems kind of limited. It's just runs on just these GPUs. I mean, is that a fair criticism?
So, okay, we make no apologies about OpenACC being universal. However, its targets are. It's not just GPUs. It is targeting accelerators, but it also can generate code for a host or for other shared memory devices. Its execution model, or its programming model, is a limited set of parallelism. It's basically regular parallelism and nested loops. It's not really doing deeply recursive and linked lists and the sorts of things that you would want to do, say, with Silk Plus. Okay, and that's another model which they would say is universal, but it pollutes how you write your, it taints how you write your program, right? And OpenACC, for the algorithms and the programs that fit the model in OpenACC, we think we can give performance portability across a wide range of targets. And we think that's going to be important.
Because that's the goal, is make things more portable, right? I mean, not
portable
have to redo this every time.
And performance portable, and future portable, right? You don't want to have to rewrite or retune your program every time you buy a different target machine.
I read something recently where it was talking about, the hardware shouldn't dictate the programming model. Or did I get that right? What was this about?
Well, you have to be able to implement your programming model. And so I also heard this, where the programming model should not reflect what can be implemented, it should be beyond that. Well, if that's true, then the OpenMP target model shouldn't have a data construct. It should just reflect shared memory everywhere, since that's what we really want.